Hi, my name's Frank Thomas. I'm with Adaptive Corporation. Today we're at the YBI facility in Youngstown, Ohio. This is the Adaptive Corporation laboratory for additive and metrology. So what we have done is we have co-located our equipment at YBI in Youngstown. And you may recognize the name YBI or some reference to it. It's also where America Makes is housed and headquartered. It's actually where it started. So in fact, they're right up the hall here. So what we decided about a year ago, we did used to have a lab that was located elsewhere, and it just made more sense for us to co-locate in this facility because there's more traffic in here, there are more visitors that come to see this operation, this facility, and you can see all of our equipment that we have here. So we're going to run through the different equipment that we have here, along with reviewing the metal making process to give you a general overview of that. Again, the YBI facility is headquartered in Youngstown, Ohio. We would love to have you join us anytime. Thank you.
I'm Jeremiah Creighton with Adaptive Corporation. I'm the Mark Forged Metal Certified Technician on the team. We're going to be talking about the metal system and the YBI facility. What really sets Mark Forged apart is their software, Eiger. What's great about their Eiger software is you're able to use that across all of their platforms, from desktop to industrial series to the metal series. With the metal series, we're able to print in various type of materials, from A2, D2, H13 tool steels, 17-4 stainless steel, copper, Inconel, and soon titanium. With that being said, once you have uploaded your part via the STL format, you are then able to pick your orientation, add layers, adjust things how you'd like, and even materials. Once that's been done, you select print. You'll print that in here. Everything is self-contained, just as the composite printers. Very similar base as the industrial series, with things being together. Once the part has been printed and removed from the print sheet, the part is in a state referred to as the green state. It's in a very delicate state at that point. It needs to be weighed. To obtain that weight, you will take it then to the wash station. There are 3 steps with this metal process: print, wash, center. Once things have been tracked, weight has been documented, and depending on the material you have selected in the design guide, you now know what you're looking for in a mass loss. All will be reflected in the Eiger software. With that, we'll move over to the wash station. As Frank had mentioned, there are 3 steps with this process. The first one, part being printed in the green state. From there, we move over to the wash station. Once the part has been washed, which is instructed and detailed with the Eiger software, it will allow you to keep track of all of the parts process as it goes through. So once you have followed the instructed time frame for the part with the software, you will then move the part from the wash to dry. That time frame is also designated with the Eiger software, allowing you to keep track of the process every step of the way. Once the part is in this process to remove the wax, depending on the material, you're looking for a certain amount of material loss. That part will then be classified in the brown state. Okay, so as I've described before, the part's now in the brown state. Once we verify this, we can then center the part. As it was mentioned, it's usually roughly around 24 hours. Our part's complete, and we're now going to remove this from the center. With the set of safety steps, we can then remove our centered part from the machine.
Today going to talk to you a little bit about the carbon fiber composite equipment that we have located here. Specifically, we have a Markforged X7 printer. So the Markforged X7 is an industrial strength 3D printer. It really specializes at creating parts that are functionally, dimensionally accurate parts and very, very strong. So the X7 prints a couple of different base materials. One of the primary base materials is this black material. We call it onyx. Onyx is comprised of chopped carbon fiber, which by definition, just chopped carbon fiber makes it very, very strong and very, very lightweight. In addition, at the same time as we're printing the onyx material, we can print one of 4 different continuous materials at the same time. So the 4 different continuous materials consist of carbon fiber, of Kevlar, which is what this material is. We can print continuous fiberglass. We also have a continuous high temperature, high strength fiberglass. So what each one of these materials do is that they add additional properties to the already very, very strong and dimensionally accurate part to make them even stronger. By virtue of adding reinforcement material to the part, we can use it potentially as substitutes for a variety of metal applications where in the past you might have used metal parts, for example, for end-of-arm tooling or work holding applications. Now we can 3D print those. The benefit of 3D printing parts that are used for work holding, in this example, this is a metal part that maybe I'm going to clamp onto for an end-of-arm tooling or for a jig or a fixture. By using the carbon fiber material and clamping onto your metal parts in production, the carbon fiber material is non-marring, so I'm not going to scratch your part, which to a lot of our customers is very important. So behind me, I have an X7. This is a Markforged X7. The benefit of the X7 is it's very, very large volume, so it's about a cubic foot in terms of print volume. It prints all of the materials that I mentioned to you a moment ago. In addition, it's got a laser micrometer built into it. And the laser micrometer is built in to be used for measuring the parts during the print and post-print to make sure that dimensionally they're accurate and correct. And the X7 is all self-encapsulated. So down here is where we have the material stored, and the printer is self-contained here. It ties to our software. The name of the software is called Eiger. Eiger is used to control all of our additive assets, whether it's industrial series carbon fiber composite printers or metal printers, or here on my left I have a desktop printer. So the desktop printer is really the same as the industrial printer, primarily a larger volume, so smaller part size rather. So for smaller parts, again, great for work holding applications. The desktop printer does not include the laser micrometer. But other than that, from a part quality and material standpoint, most of the materials that we support on the X7 are supported on the desktop printer. On the X7, we've introduced a couple of new materials that are unique to the X7 that are not supported on the desktop printers. One of those materials is called an Onyx FR. FR stands for flame resistant. So great for some aerospace applications, for weld fixtures. If I'm going to be welding and I'm sensitive to material melting or catching fire. We also have introduced a white nylon material, which has some great interesting applications, and those materials are unique to the Markforged X7 industrial printer. Thank you for watching. The purpose of this part of the presentation is to introduce you to the software that we use to interface and control all of our printers. The name of the software is something called Eiger. It runs in a simple browser. Eiger allows us to be able to control any kind of printer or any kind of 3D printing additive asset that we have on the network. So in our case, it's going to be a metal printer, it's going to be a carbon fiber composite printer. On the carbon fiber composite printers, this will control the industrial printers as well as the desktop printers. And the way that it works is quite simply, I open up an STL file. So this is the impeller that was created for us in CAD. In CAD, we said File, Save as STL. In Eiger, we said File, Open STL, and it brings it into our view like this. The grid on the bottom represents the print bed. And then I select the material that I want to print it out of, and if I want any reinforcement material, any carbon fiber or continuous fiber reinforcement material. So for this example, I'm going to say, no, I'll just print it out of the base carbon fiber material, Onyx. And this is what the internal view looks like. So if I had the ability to do an X-ray view of the part, this is exactly the way that it would look, and allows me to see the architecture of the part, the infill. I can view the part layer by layer, so I can actually see by hitting the right mouse or right cursor button on the keyboard. I can see layer by layer. Here's exactly what the toolpaths look like, including the infill. I can go back to my 3D view. Now, let's say that I want to add some continuous support to the part. So I'll view this version of the part where we did add some continuous carbon fiber reinforcement. And under the reinforcement settings, we said, well, we'd like to have 50 layers of continuous fiber, and we'd like that laid up concentrically. So if I look at the internal view, it'll allow me to see, here's the way that we've got the part or the continuous fiber laid out inside of the part. So in this example, I did it concentrically, and I also did it isotropically. So across this base, you can see the isotropic pattern, and you can see concentric around the outer walls and the inner walls. So I can control exactly where the continuous fiber reinforcement gets placed on the part. Hi, Frank Thomas from Adaptive Corporation again. Again, back at the Adaptive Additive Manufacturing Lab in Youngstown, Ohio. Earlier we were talking about 3D printing parts here. We can 3D print metal parts, we can 3D print carbon fiber composite parts. One of the services that we offer that we think is unique in this facility is we have the ability to 3D scan parts after they have been printed. Why do we 3D scan parts after they've been printed? Is by doing that we can ensure you, our customer, that the part meets your nominal dimensional accuracy requirements. So by using the 3D scanner that has accuracy of 30 microns, we can 3D scan the part. We can, within minutes, take the CAD version that created this part. We can overlay the 3D scan of the part that came off of the sintering oven or off of one of the carbon fiber composite machines. And within a minute or two, we can tell you if the physical part matches your CAD model. If it's out of tolerance, how much out of tolerance is it, and exactly where is it out of tolerance. So we have all of this capability here at the Additive Manufacturing Lab. In addition to inspection services that we offer here at our lab, we can also perform reverse engineering work. So if you have a physical part, but you don't have a CAD model for it, and you want us to generate a CAD model from your physical part, we have that ability as well. Thank you for watching, and please keep us in mind for future reference.